Okay, that's a model assumption and what? We need for the PERT CPM 3Estimate. So let's work on example 3. So you know how you can actually apply to the calculation, also Excel spreadsheet. Beer Franklin, President of Lincoln Log Construction, is considering placing a bid on a building project. Beer has determined that 5 tasks would need to perform to carry out the project using the PERT 3Estimate approach. Beer has obtained the estimate on the table below for how long 3 tasks will take, also shown as a precedence relationship for this task. Okay, so this is a one. We have 4 tasks, A, B, C, D, E, or you can say task 1, task 2, task 3, task 4, task 5. 5 tasks. And task A, activity A, if everything goes smooth, nothing go wrong, people finish in what? In 3 weeks. But something, usually, one or two things will go wrong and delay what? The work. So most likely it will be last for what? 4 weeks. But if a lot of bad things happen, it can run as long as what? As long as 5 weeks. Okay? And there is no immediate predecessor. Okay? So folks, what I want from you is based on the information. Okay? You want to construct what? A project network for this project. Okay? Use what? AON project network. Okay? Use the information I just provide you, but do it later. Okay? There is a penalty of $500,000 if the project is not completed in what? 11 weeks. Therefore, Beer is very interested in how likely it is that his company could finish the project in time. Okay? So what I want you to do first from you guys is what? I give you 2 minutes. Try to draw what? The project network. And after that, we're going to use Excel. You learned before in last class to set up an Excel spreadsheet. Okay? Now, 2 minutes to work on what? Question number 8, please. Can you see my screen? Okay. The AON project network. Start. A has no predecessor, so start link to A. B is after A. B is after A. C is after B. D is after A. D is after A. And E is after B and D. After B and D, this is E. So C, E are the last 2 activity. Okay, so they link to finish. Take a good look about the graph, AON project network graph. We're gonna apply the information in Excel spreadsheet. Okay. Okay. We begin with what? The Excel spreadsheet application. Give a application a title, right? PERT CPM, 3Estimate example on Lincoln Road construction. And we have activity A, B, C, D, E. All you say is task 1, task 2, task 3, task 4, and task 5. Okay? And from the given information, let's enter the information one by one.
It's historical.
Okay? So look at here. This is a given information. Task 1 or activity A. Optimistic. If everything runs smoothly, it lasts for 3 weeks. But something will definitely go wrong. Hopefully not very serious. So most likely last 4 weeks. when every bad thing happens, it can run as long as what? 5 weeks. Okay? Okay? So we're gonna use what? We're gonna use the formula introduced earlier to figure out the mean and the variance. Okay? The mean and variance. So look at here. The mean going to be optimistic plus 4 times what? Most likely plus pessimistic. And then you divide it by 6. So the average is what? Is 4 weeks. And we use relative address, copy it down and get all the rest activities. Okay? But I don't want they carry so many digits. Let's just use what? 2 decimal places. Okay? And variance use a different formula. It's pessimistic subtract by optimistic and raise the power of 2. And here, and here you divide it by 6. No, I should divide it 6 here. Okay? E4 minus C4 divided by 6 and the whole thing what? The whole thing square. Okay? And then you copy that. Again, I only want to take what? 2 decimal places. We're gonna have early start time, latest start time. Earliest finish time? Oh no, this is earliest finish time. And this is the latest start time. And this is the latest finish time. And you want to find slack. If you look at your project network, you find a link directive start. So it can begin with what? Time 0. Or you say now. Okay? And use the relative address feature. Earliest finish time is always equal to earliest what? Start time. Plus the mean duration. And then you can just what? You can just copy it down to the bottom. And then the second one, B is right after A. So the early start time of B is earliest finish time of A. See, when you enter this one, this number will change automatically. Okay? Now, C is right after B. So early start time of activity C is earliest finish time of its what? Huh? Predecessor, which is B. And D is after what? D is after A. So D's earliest start time is the earliest finish time of A. And E is after what? E is after B and D. So this is a forward pass, okay? Forward pass. You can use what? Forward pass. E is the successor of B and D. So you need to use what? The max. Use max for forward pass. Okay, let me organize the cell. Let it look like a little bit nicer. Okay, and then the project completion time. Project completion time going to be the maximum on what? Earliest finish time in the forward pass. So the project expected duration, the average, the mean project completion time going to be 10.83 weeks. Project time, I hit the formula tab and create from selection. And the name I want to give it to is what? To the left column. That's what I want. Okay. So we look at 10.83. You find this is project time. Okay. Now, in the backward pass, if you look at the project network, C and E are linked to finish. So we need to what? Begin with this. And the relationship between LS and LF is always equal to LF minus what? Minus the mean duration. Don't worry about that minus 4. You will update it when you enter the number one by one. Okay? Now let's work on task 4, activity D. D is what? D is right before E. D is right before E. Okay? D is right before E. So the D's latest finish time need to match with what? The latest start time of E. Otherwise, postpone E, the whole project will be delayed. And same thing. B is what? B is right before C and E, but this is backward pass, so we take the minimum. Minimum of what? Its successor. C and what? C and E is immediate successor's earliest finish time. And A is a predecessor of B and D. So you take minimum again. And done. I made a mistake, okay? This one actually should be what? This one should be J6. And this one should be J8. Okay, and that should be correct. And then this one, I need to update it to what? To minimum. Activity A has two successor, immediate successor. So in order not to have the project delay, the latest finish time of A should be matched with what? Latest start time of B and D. Okay? And B is what? 4 weeks. And D is 4.67 weeks. Okay, then this should be correct. And next one, we can find slack. You can use latest finish time, subtract earliest finish time. Or you can use latest start time, subtract what? Early start time. They should give you exactly the same answer. And next, we want to find critical activity. Use if statement. If the slack is 0, then we say yes. It's a critical activity. Otherwise, we say no. It's not a critical activity. And then we just copy it down. Okay, this is just like a last class. Okay. This is part of target to find out it's on the critical path or not. So I use the color orange. Okay. So we can answer the question one by one. Okay. Answer the question one by one. Okay. Find the estimate or mean and variance of duration of each activity. The answer is C what? C4 to E8. That is this block. Okay. You can find, oh, sorry, it's from here to here. Okay. So I should change. From what? From F4 to G8. Okay. So let me change it. So this one should be what? This one should be from F4 to G8. Okay, that's what we're looking for. Look at the last column. Critical or not? Yes, yes, yes. No, no. So the critical path is what? Activity A, B, and C. Okay? It's from start, goes to what? Goes to A, goes to B, goes to C, and then go to what? And then go to finish. Okay? That is the mean critical path. Okay? And then look at the next question. Okay? Question number 4. We want to find approximate probability of completing the project within 11 weeks. To find this probability, we use normal Excel function as follows. First one, we set up the mu. Okay? Mu is what? The mean project completion time. And mu and what? And variance, sigma. Sigma what? Sigma square. Well, just sigma. That's fine. Let's do sigma. Okay. So what is mean? Well, let me what explain a little bit here. Okay. First, we set up mu. Mu represents the mean project completion time, and sigma, the standard deviation of project completion time. Okay, the standard deviation of project completion time. We use what? Sigma. Okay, mu and sigma. Okay, now what is the mean project completion time? Mu is a mean project completion time, which is equal to what? This one we find earlier. Okay, it's a mean project completion time, which is followed from here. And sigma, hmm? Actually, I should begin with the variance. Okay, variance of project completion time, which is equal to the variance is determined by what? Uh, A, B, C. And we need to add up its respective variance because we assume they are independent. So that's going to be this number. The the critical path is A, B, C, right? So the variance of A, if we assume they are independent, plus the variance of B, plus the variance of what? C. So that add up to what? The variance of project completion time is 0.36. And standard deviation is what? Standard deviation is square root of the variance. Let me use range name. Okay, let me use range name. Uh, Formula, create from selection. And okay. Now, sigma, the standard deviation of project completion time going to be the square root of the variance. So that's about what? About 0.6. So look at here. The probability project time going to be less or equal to 11 weeks. That probability we're going to use what? We're going to use normal distribution function. Okay? This is for standard normal. This is for normal. Okay? If you use MORN dot S, that means you standardize to Z-score already. Okay? Now we did not do so. So we use what? Normal dot DITST. Okay? We use this one. And X going to be what? 11 weeks. The mean is 10.833. Okay? The mean project completion time, 10.83. And standard deviation is what? 0.6. Cumulative, you just enter 1. That means true. Okay? And then when you hit the enter key, you're going to get the answer. The chance is what? About 60%. Okay? It's about 60%. So, what is your advice on bidding what? The project for the company. So let's look at the expected profit first. Of course, there are many other what important factors, but let's calculate what is the expected profit. Probability of what? Let's look at probability of meeting the schedule. The probability of on time is just borrow for its number. Okay? And probability of miss the schedule is 1 minus on time. Okay? So the expected profit, let's see, the profit going to be 250,000. The profit is 250,000, but the penalty, if miss the schedule, is also what? 250,000. So the expected profit expected return. Okay. Going to be huh? Profit times what? You have a profit 250,000 when the project completed on time. But if schedule is missed, okay? Uh, I I should put a minus, but that's fine. I can put a minus here. Times what? The probability of miss. So the expected profit going to be $54,622. Okay? Of course, there are some other factors, but this one tell you huh, the expected return of working on the project. Okay? Uh, there are other factors you need to take into account. For example, how many people involved with what? The project. If you have a lot of people involved with the project, the expected return this amount probably not very good. But if only like a couple people, 4 or 5 people, then maybe what? Maybe it's a good investment. Okay?